do you want to highlight? I think you should be able to annotate on the diagram. I've just made it a bit bigger. Okay, activation energies, and then we'll do the enthalpy calculations after this, okay? And that should get you nice and set for the test.
Um, does exothermic start lower, or is it where it starts higher?
You asking me?
Yeah,
All right, okay. What do you think?
I think it's I think it's higher because no, it's lower because it um gains heat because it like absorbs it, so it would gain heat.
I have a question for you. What do you understand by the difference between exothermic and endothermic?
Doesn't does exothermic like release heat in a reaction?
Brilliant. And then what does
And
endothermic
endothermic endothermic
takes in heat?
um takes in heat,
That's absolutely
so it
correct.
like makes it colder.
Absolutely correct.
So then for exothermic it get would it be like oh I can't draw.
Here you go. Try drawing again.
So like somewhere then there's kind of that thing.
Good job.
Would this be like is this the activation energy?
That is the activation energy.
And then
All right. The activation energy is from the base of the reactants to the top of the curve. So you have to go all the way down to the base of the reactants. Good job. All right, cool. Now let's talk about this, okay? Um, so before we even carry on, I urge you to just take a second and think about what you told me about exothermic releasing energy and endothermic taking it in. What do you understand by that?
um so in like exothermic reactions it just like it would release heat.
Okay, if it
So
releases
then it would be
if it releases
so
heat,
something would get hotter.
yeah, so I mean the air around it will get hotter, right? If it's releasing heat,
Yeah.
you think it will have more energy at the beginning or less energy at the end if it's giving out heat to its surroundings?
It would have less energy because it's
Okay,
losing thermal energy.
exactly. Good. That's brilliant. Such brilliant analysis. Now, Lisa, look at what you did. You drew.
Oh,
Yeah. Right. So clear that up and try and draw as neatly as possible. Right. Always start in the middle, roughly. It's always best start sort of in the middle and then go from there. Okay. Okay. Go on. You should be able to draw it now. Good job. Maybe give it a bit more of a peak so it can have a little bit more activation energy. Just a little bit more. Just let's give it a little bit more of a peak. Brilliant. Um, and then in an exam as well, they'll want you to definitely write something like reactants on top of the dash and products, or maybe instead of reactants, put H2G plus Cl2, or just H2 plus Cl2. That'll be so much better. Good job. And then at the bottom, let's just put 2HCl. Great. And then let's put the activation energy. Remember, it's from the top to where? What did I say? The base of what?
they're from the base of like this,
The
like
reactant.
so like that.
The reactant. Base of the reactant to the top of the energy curve. Okay, cool. The base of the reactants is over here, right? Um, if you think about this is the base of the reactants. So you draw it from just from here to here, okay?
Oh, okay.
Yep, the base of the reactants. Feel free to, yeah, good job. Good job on that. Yep, go on. So put your line back, the line back, and then you're good. Sweet, good. And that's activation energy. E with subscript A can also be written as activation energy. So we write it as that as well. Okay, no E's. EA, activation energy, energy activation. All right, cool. So that's your EA. Brilliant, good job. Do you get that?
Yeah.
Sweet. All right. And that's how you'll always figure that out. Don't try and memorize. Just remember what's exothermic, giving out heat. Therefore, heat release energy. Therefore, it's less energy than the initial thing you started with. Right? Okay.
Yeah.
All right. Good job, Lisa. You're doing really well. So let's just go to the last thing, which is the question that you asked me from the beginning. Okay. This, right? And this is exactly what you were looking for, wasn't it?
Yeah.
Right. Let's do it together then.
Is it where you do the um delta, like, is it n? I can't remember what the equation is.
Um, I mean, I think what I would like us to do is just find the equation, just do bonds broken, find the bonds formed, and the energy change is just bonds broken, take away bonds formed, right? And that makes sense, doesn't it? Right? So if you just think about it, we're just going to find bonds broken, take away bonds formed equals energy change. And you know that makes a lot of sense, right? Because like what we did to for the reactants to start reacting, we break the bonds, and for the new products, we form bonds. So the energy change is just the bonds broken, take away the bonds formed. So what I'd ask you to do first of all is tell me what's the equation of the bonds broken? What bonds are broken in this equation? H2 plus Cl2.
Yeah.
So what bonds do you think are broken?
Um, Cl2
Yep,
and H2.
good. And by the way, it's not two. It's not. If it was a two in front of the H's, it would be two sets of these. But it's one bond broken is H2. Okay, so that means the total energy of bonds broken is going to be. I'm asking you that question. What do you think it's going to be?
Oh, um, would I just have to do H2 minus
So this is the energy of the bond that you just mentioned. H2 is broken and Cl2 is broken. So the bonds broken is you add them. H2 broken plus Cl2 broken, right? Does that make sense? Or should I put in an extra step?
um no, that makes sense. But
Sure.
yeah,
Yep. So then can you tell me what bonds formed would be?
679.
Bonds, okay, yeah, that this would be 679. Perfect. So bonds broken is 679. Brilliant. All right. And what's the total energy for bonds formed?
Um, 193.
Bonds formed. What bonds formed? Tell me.
Oh, 430. Oh, so it's 2H and
Yes.
then Cl,
Yeah, no, it's two times HCl. That two is outside the entire thing. So it's
and
two
then so you have
of so it's two of the HCl. So what's it going to be?
1,358.
Nope, not quite. It's two of HCl. It's two sets of hydrogen chloride.
Oh, okay. 864.
Correct. So it's two times what? 432, right? Which
Yeah.
equals 864. So then what's the energy change? If it's bonds broken, take away bonds formed.
Um, minus 185.
All right. So how do you think that went? By the way, minus 185 is absolutely correct. Yep. So how do you think that went?
Um, I think it went all right.
Yep. So what do you think you could do better next time just to make sure you don't make the same mistakes?
Look if the two is like the small one or the one on the outside.
Correct. The one on the outside multiplies everything, right? So for this one, we broke two sets of HCl, right? HCl. Whereas for this one, right, we broke one set of H plus, and we broke another set of Cl, right? And then that's Cl2, H2, and this is 2HCl, right?
Yeah.
Okay, cool. So that brings us to that practice. Okay, so that's the enthalpy chain question as you asked for. Take your time and just write it all down. Okay.